in this video I want to show how you can use my Wobbulator circuit. And a Wobbulator means that we test a radio coil under certain circumstances. We test it on its resonance frequency, we test it on its Q, its quality, etc, etc. So I want to refer to an earlier video that I made, and will give the link in the description about that earlier video. But anyway, say we have here, and in a certain way, my heritage. This is a shortwave antenna coil, and here quite a bunch of coils that I made in the past and tested to say whether they oscillate in an oscillator circuit. Could be with a field effect transistor or with a normal, say, B.t.w transistor. Many circuits of that are on my YouTube channel. Anyway, so the field effect transistor in general works better, especially when you want to go to higher frequencies. And for instance here, this is a typical coil for higher frequencies. This one here. And it works up to, well, I think approximately 14 megahertz. But well, there's a lot to tell about coils that work on higher frequencies, and then with higher I mean higher than 12 megahertz. In general, they must be made with silvered wire, and that has everything to do with the so-called skin effect. Today I did an experiment with copper wire that I tinned and then made a coil, but no result. Anyway, but in the past I got good results to get higher than 12 megahertz with silvered wire or even silver wire to make such a coil. Anyway, so this is in my opinion important, and when we look at this big bunch of coils, what can we tell about it? Well, when we look at the standard radio theory, there is a relation between the diameter of the coil, the spacing of the windings, etc, etc. So you can directly see here that I did a lot of experiments. And the good thing of that Wobbulator circuit is, can we get such a coil into oscillation? Well, here, for instance here, can we get this coil into oscillation? And when it works in an oscillator circuit, you know that it has a certain quality, say Q. I don't want to elaborate on the Q issue. There's a lot of scientific information about the Q, the quality of coils, on the World Wide Web, Google, etc, etc. But I'm more or less always interested in how that all works in practice. And for instance, here you see a coil that I made in the past, and it works between 6.3 and 13.3 megahertz in an oscillator circuit. This is an experimental coil. I think it doesn't work. This is a coil that surely works. When you make a coil in a proper and neat way, like here on a PVC tube, it works. And say the waveform of the oscillator has also everything to do with how you make such a coil. When you make it neat in the proper way, you have a perfect waveform, and when you make it sloppy, you don't have a perfect waveform. So here 3 up to 6.6 megahertz. And here, well, anyway, so the big bunch, this is also, say, an interesting coil. Anyway, so look at this big box with everything. And by the way, this is a very high frequency coil that I tested and made. It's only one winding. I want to refer, say, to the standard coil theory about this coil and how it was made and why it was made in this way. Anyway, at the moment I'm looking at this coil that I made. Oh, camera drops suddenly, sorry for that. I have to fasten it again. The coil that I made in the past here, it works on the Wobbulator and it works here. You see the waveform, you see the peak resonance, and here we see the frequency. Though I have to say, at the moment, perhaps I cannot see it, but anyway, I don't want to say skip this video. There is, of course, say, a very good resonance on this frequency, and this is the peak resonance. So let's go to another coil. Say, for instance, this coil. This is a simple coil made on PVC plastic. Let's try. Connect it here, and of course you can do all these experiments yourself to see whether the coil that you made works in practice and has a good resonance. And that's always, say, the key. So I connect now this. I turn the, well, the oscillator doesn't want to work. Yeah, I tested it yesterday, but anyway, now, but of course perhaps I have to do some alignment. Well, here it oscillates. Well, that's okay. So here we have this coil, 20 windings, 20 windings, 1 millimeter wire, and here it is on the Wobbulator, and here we have the waveform. And sorry that I cannot show the frequency, but anyway, when you are a serious radio amateur, you can surely know where this works. See, this is the peak resonance. I'm now on 8 minutes on my video. Let me try to get the oscillator into a functioning circuit. Well, that's a serious problem, because a wire is broken, was broken. Anyway, try it again to get, say, an indication about the frequency where it works. So, well, I hope it works now. This is the coil, and also here you have to, say, get an idea about where a coil works. For instance, such a coil works in the shortwave range, and this one also. And this coil is more or less unknown to me, but anyway, we have a frequency, we have a resonance, and perhaps we can see where it works. Could be that it works on 555 kilohertz. But anyway, you have to check such a situation over and over, etc. So here's the Wobbulator again. Let me show the, say, standard shortwave radio coil. That's here. Here, a radio coil, standard radio coil for, say, 3 megahertz up to 8 megahertz or so. That depends, of course. You can stick in here a ferrite rod, and in that case the frequency goes down. And here we have the same situation, by the way. Also here, good quality standard antenna coil to receive radio stations on shortwave. And here you see the windings 11, 8 and 7, made with wire, with a massive here core, isolated with high quality plastic. It came out of telephone wire. And of course, say the telephone wiring has to have extremely high qualities, because otherwise you cannot get, say, a good connection in telephone terms. But anyway, so this is what it is, and you can replace it or also use it. So let's go to that coil. How does it perform on the Wobbulator? Well, so let's try to get it into oscillation. Well, here it is in oscillation. That means that we have a waveform here on the scope that is connected to the circuit, and here we have the peak resonance. So I think that this is or was, you can change the frequency, by the way, here. What's the frequency where it's working at its utmost? That is 1.5 megahertz. I had not expected that, by the way, but anyway, that is, say, the pure idea of the whole circuit, that you can test such a coil on its real frequency where it works at its best. Thanks for watching. I think this was enough, or perhaps too much. Anyway, oscillation gone, start oscillation, and here we see the resonance peak on 1.4 megahertz. Thanks for watching again.